Hello, my name is Mark Ellis from Stick and Rudder Studios, and this is the third preview video for some of the new features in X-KeyPad 1.5. And today what I want to show you is a brief overview of the new formula features that we put in to X-KeyPad. Now, for those of you who have done X-KeyPad configurations before, you are probably aware that as you get into more complex key layouts and wanting the ability to have keys that contain multiple pieces of data on them that are very dynamic and change with what's going on in the simulator, often you can't do this entirely with X-KeyPad. You often have to resort to developing some Fly with Lua scripts. And although Fly with Lua is extremely powerful and you could do pretty much anything you need to do with it, it is a full-blown programming language, and it does have a bit of a learning curve, particularly for somebody who does not come from a programming background. So what we wanted to do is build something into X-KeyPad that was a little lighter weight, that you could use for many dynamic data manipulation right with an X-KeyPad that didn't necessarily require a huge amount of programming expertise. And that's what we tried to do with formulas. So first, let me bring up the formula editor and show you what that looks like. So you can get to the formula editor either right in here from a virtual device, or if you happen to be working with hardware devices, I'll just move this out of the way here. You can also get at it from under the X-KeyPad plugin menu, and we'll just bring up the formula editor. Now I have a couple of formulas already defined here, but let me walk you through the structure of what a formula looks like. First off, over here in this left-hand window, you're going to see all of the formulas that you've defined. And you can have up to 100, and it's frankly pretty easy for me to add more, but I think 100 is more than anybody's going to want to be able to deal with at any given, point in time. If you hover over the top of this, you'll actually come up and show you whatever you gave the formula name for. So this formula is actually calculating the selected fuel in kilograms. And here's another one calculating the flight time I have in hours based upon what fuel tanks I've got selected. I also come up here and I can say expand formula names, and what this simply do is it'll break it out and it'll actually show you the names of the formulas here. So in case you want to quickly find one, if you have quite a few of them that you've defined, finding the one you want to work with might be a little bit easier by doing this. Okay. Then, given whatever formula you've got selected here, over here on the right-hand side is where you'll actually do your formula definition. Now the formula is made up of a couple of different parts. The first part is an optional result data ref, and this is again optional because the result of a formula is always going to go into a set of arrays, data refs arrays that we created dynamically for you. Just like you've got the shared floats and the shared ints, the other thing we've got is an array of formula data refs. So there's formula floats, and there's 100 of them because you can have up to 100 formulas. And there's formula integers, which is nothing more than the float results represented as an integer. And again, you could have 100 of those. And the formula index that you see over here, like 0 or 1, that's going to be the index into the array. So anytime you define a formula, the result of that formula is going to automatically get put in these arrays. However, you can optionally tell it that I want it stored in a particular place. And this data ref can be, it could potentially even be a simulator data ref. It could be an aircraft data ref. It could be one of the shared floats or integer data refs, if you wanted to do that. And but you don't have to put this in if you don't want to. Okay. By the way, we'll get to this in a minute because in Formula One I actually do something really interesting. This data ref could actually be a custom string data ref, which has got some advantages depending upon what you're trying to do with the formula. So in this case, for Formula 0, the name of this is selected fuel in kilograms. I'm just going to go ahead and let that store that in float index, formula float index 0. And you can actually see it here, the value is calculating to be 114.26. And you could see down here, in this, in this formula float array down here, it's actually 114.23. So you can see it's actually updating. Okay. The next part of a formula is going to be whatever variables you want to work with. And variables are always associated with a data ref. So in here, I've defined variable 0, and I gave it a name. It's called fuel under bar L. And that's the way you're going to reference it when we actually get into the expression for the formula. And I have the data ref that's behind that, and it happens to be the Cessna 170 tool fuel quantity on the left tanks, which happens to be in kilograms. And here it's showing you what its current value is. The next data ref I've got here is the right-hand fuel tank quantity in kilograms, and I call that fuel under bar R for that variable name. And the last data ref I have here is the tank selector. And this is actually, if we come down here, that's actually this. So as I turn this, you're going to see that this value here, tank selector, goes from 1, it goes to 4 if it's in the both condition, and it goes to 3 if it's over in the right condition. So we're going to use these variables to come up with a calculation that's going to show me the total selected fuel in kilograms based upon how I've got this set. So, clearly if I'm in the both position, both tanks are available to my engine. So it's going to be the sum of the left and the right. If I'm over here in the left position, then the available fuel is only going to be what is in the left-hand tank. And if I'm over here in the right position, the available fuel is only going to be what I've got in the other tank. So how do we do a formula that does this? Okay. So the next part of a formula, once you've got the variables, is the expression. In here, you've just got a little text editor, and we can put the expression that we want in here. And hopefully this is not too difficult for you guys to read. But it says if the tank selector equals 4, then, and the way these if statements work within this expression, this formula expression parser, is it works very similar to what you see in Microsoft Excel. The first part of it is the test, in our case, tank selector equals 4, comma, and then what you want the mathematical expression to be if that happens to be true, and then comma, what you want the expression to be if this first one happens to be false. And you can nest things. So you can actually nest the if statements if you wish. So let's go walk through how this one works. If the tank selector is set to 4, which is basically the both condition, as you can see that here, right? If I come up here, it's set to 4. So if it's 4, I want to add fuel left and fuel right, and that's what's going to get returned, as part of the formula. Now, if that doesn't happen to be true, in other words, if it happens to be, either a 1 or in this case a 3, it's going to fall through, and we're going to do the next test. And here it says if the tank selector happens to be 1, then what you want to do is return fuel left. And if it's not 1, the only other choice is 3, so I don't need to do another conditional. I'm just going to return fuel right, okay? Because if it's 3, that means I've got the right-hand tank selected. So as you can see, this is the result that's getting returned back, okay, as part of that formula. And you watch, if I change the tank around, you see it's going to come up with different values, right? The left tank's got 73 kilograms in it. Both tanks, the sum of that is 113 kilograms. And the right tank's got 39 kilograms in it. If I come over here and look at the fuel tanks, if I come in here and zoom in, you can actually see that it's showing that I have far more fuel in the left tank than I do in the right tank. Okay, and that result is getting stored down here in this formula float array into index 0 because that happens to be formula 0. And we actually can expand this a little bit and you can see it. 39.712, that's the result that's coming out here. Okay? And the other thing you can do with the formula is you can put in comments. So, here I've got the whole little discussion about, how this formula works and what it does. And that's all going to get saved with your configuration. Okay? Now, you can have formulas drive the input to other formulas, and that's what I've actually done over here in Formula 1. Now, what Formula 1's going to do is it's going to try to calculate the fuel time you've got in hours based upon what your tank selector is set to. And I mean, obviously, if you've got the tank selector in both, you've got that total fuel quantity that you can fly by. If you're a bonehead and you left the fuel tank selector over and left and completely forgot about it, then you've got a certain amount of time to fly. If it's over on the right, you've got a different amount of time to fly. So if you wanted to do something like put an indicator, up on your keypad that tells you how much flying time you've got left based upon how you've got your fuel tank selected, this is what this kind of does. And a real Cessna 172 doesn't have that. You have to keep your wits about you and remember, what fuel tank you've got selected and how you've got it done. But you could do this if you wanted to. So let's walk through how this formula works. So here I've got the name up here, fuel time in hours, and it does have an optional data ref. And in my case, what I'm going to do is I'm going to store this in custom string 10. Now, what that means is that if I'm going to put it in a custom string, I have to convert it from a float to a character string. And that's what this format string down here tells me to do. This is telling me I want a total of 4 places, and I want 2 decimal places to the right, okay? And what it's going to do is it's going to convert the result of this formula, it's going to convert it to a string and put it in the custom string variable based upon how you've got this format set up. Now, just for a minute, why don't we talk about why that's got an advantage? You might ask us, well, why am I bothering putting this into a custom string? Why couldn't I just use it, directly out of, one of the float variables? And you can, but one of the current limitations, which I might try to enhance down the road, one of the current limitations of the label layout on a key is you can only get data either from the numeric data ref or from the logic data ref. In many cases, that's good enough. But sometimes you want to build up a key where, on one line you've got one piece of data, on another line you've got a different piece of data, and you might even have a third line with a third piece of data, and all this does not necessarily come from either the logic data ref or the numeric data ref. The beauty of custom strings is you can put them on any line on the key in any line segment. So it's got a lot of capabilities. So that's where it could be advantageous to take the result of this formula and pre-format it into a string data ref that we can then use any place we want in the key, regardless of what that key has for a logic data ref or a numeric data ref definition. Okay? So so we know that when this result comes out, we're going to stuff it in this string based upon that formula. Now, let's take a look at this variable. This variable is actually taking, as one of its inputs, it's taking the result of formula 0 up here. And you can see that because the data ref I'm pulling it from is formula float index 0, which happens to be this formula up here. So it's taken the 38.97, which is the total quantity of fuel in kilograms based upon how my tank selector is set up, okay? And then what's the calculation we're actually going to do? So if I come up here and look at the formula expression, it's going to take the selected fuel, which is what I named that variable as, and it's going to multiply it times 2.2, which if I remember how I did my math correctly here, that's going to convert it from kilograms to gallons, or basically to pounds. And then we know that a pound of avgas, or a gallon of avgas, okay, weighs 6 pounds. So by converting this now calculated kilograms to pounds, dividing that by 6, that's going to come up with the number of gallons that I have available based upon what my tank selector is set to. And then a typical Cessna 172 on average, between the takeoff and the landing and the cruise, on average it burns about 8 gallons of fuel, per hour. So if I take this calculation, get it to gallons, and then divide it by 8, it should come up with what's the total flying time in hours that I've got available. So I have 1.78 hours of fuel available. Now, I might not have my math perfectly right here, but I believe this is pretty close, okay? I'm primarily trying to do this as an example to show you how this works, okay? So that's the kind of stuff you can do, with formulas. And again, you could have up to 100 of them. Now, a couple things to be aware of. Formulas are going to get evaluated from top to bottom. So each time a flight loop comes along, it's going to evaluate Formula 0, then it's going to do Formula 1, then it's going to do Formula 2, etc. So if you have formulas that feed other formulas, the order may or may not matter to you. In a lot of cases, it's not going to matter because it's doing this in every flight loop. So, in the end, it's not that critical. But be aware that they do get calculated and evaluated starting at Formula 0 on up through however many formulas you got, okay? If you don't like the order, you can move them around with a typical drag and drop thing here. Now, a couple things to keep your wits about you when you do this. Formula 1, as we've got right here, is reliant upon this variable coming from that formula float data ref, index 0. If I swap these, what's going to happen is the formula that's calculating my total selected fuel in kilograms is going to end up in index 1, and they're going to get reversed. And this whole thing is not going to work anymore, right? Notice now that it's calculating I got 0 hours available. And that's because this formula is trying to pick up something from formula float 0, which has got, no data in it because we swapped the indexes around. Now, if that matters to you, the way you would make this work is, and I'm going to put them back, the way you'd make this work is you'd come up to this formula here, and rather than having it go, by default into formula float 0, which is that index 0, you could actually force it into a particular data ref. So as an example, if I came along here, let's say I want to put it into one of the shared floats. I'm going to paste it here, and I'm going to put it into shared float. I don't know, maybe I'll pick like 8. Okay. Now I could come back over to this formula. Okay. And rather than taking it from there, I can copy that, paste it in here, and put this one to 8. Okay. Now I got it kind of hardwired. This first one here, Formula 0, it's putting its result into shared float 8, and Formula 1 is taking its selected fuel variable from shared float 8. Now, if I swap these around, there should be no problem, okay, with it working. Notice that the values still work. Because what I've done is I've hardwired the output of one to a specific data ref and the output of another to another data ref. And that's a great way to do it. The only challenge with doing it this way is that, you now have to keep track of what did I use for shared float 0, what did I use for shared float 1. You kind of have to keep your wits about you so that you don't end up with multiple formulas or multiple logic tests or even your Lewis scripts reusing a shared float or shared integer and then colliding with one another. So all this stuff is really powerful, but you do kind of have to keep your wits about you as to what you're using where and to make sure that you don't end up reusing things because they can cause really rather odd logic issues or odd stuff showing up in your keys. Okay, so I think that gives you an idea of how this works. And let me just make sure if I went back here, this is going into custom string. So just to show you, that I can do that. Let me see if I can figure out a place to put this. Maybe what I'll do is here is I'm just going to go ahead and make this a little bit bigger. and I'm going to give this thing one extra column. And I'm going to come here to this key here, and I'm going to bring up the key editor. Move this out of the way. And I'm going to add a conditional key. I'm going to say it's a complex key. Line segment, and I'm going to make this here a custom string. And we want custom string 10. And if I did that right, if I bring this back over here, sure enough, this key over here is now showing me the total number of hours I have left to fly. Okay, and just to show you, I can put this on any line. So I used it here. I can add another line. Come to line 2. Let me collapse this one. Segment 1. We'll change that to custom string. Put this up to 10. And now you see I've got it in there twice. Okay, and I could even do things like add a new line segment. In this segment 2, I'm going to say it's text, and I'm going to say hours. I think I'll put a space in there like that. See, now it says 1.73 hours. So you could see the advantage of using the custom strings as an output is that's capable, regardless of what you've got for a logic data ref or a numeric data ref on that key. You can use any one of the 50 custom strings, anywhere as you want on the key. So it does have some advantages if you've got a key that's built up with a lot of different pieces of information on it, like you want a complex enunciator or something of that nature. Okay, so I think that gives you an idea of where we're going, with the formula capabilities. You should be able to do a lot with it. It won't do everything, because as we pointed out, the expression capabilities are not. It's not a full-blown scripting language like Fly with Lua. It's basically a mathematical expression capability with some if statement type capability, but it doesn't have an infinite amount of logic that you can do with it like you can do in Fly with Lua. But it should cover quite a few cases, and it should make it a little bit easier for those individuals that are not necessarily coming from a programming background. Okay, so I hope this feature proves to be useful. This is going to be in the next beta of 1.5. Beta, I think I've actually got it in here. Let me really quick and look which one it is. Yes, it's going to be in beta 15, which I'm going to release very shortly here. But I wanted to get this video done so that people can see how to use it before I get all the documentation and stuff done on it. Okay, thank you very much, and I hope you guys enjoy this new feature.